So the system is going to be started by the disc, circular disc. It's going to bring the ball to the ramp, and the ramp is going to launch the ball off the system. So how we start the disc from moving is this circuit right here. This is the engine, this is the switch, this is the battery. The battery is the thing that has the voltage. The engine is the thing that has the resistance. The switch has a little bit of resistance, but it's so little that we do not count it. And the battery is going to be causing it's going to be giving power to the resistance, and it's going to, and the engine is going to be taking all the voltage off of the battery, and it's going to use that voltage to turn the disc. So the disc is going to be using this symbol, which is called torque, to move the ball. And to find torque, you have to do force times radius, the radius of the disc. You can also find it by using I times alpha, which is angular acceleration, and I is the moment of inertia. Moment of inertia is resistance to acceleration. And the I is 1/2 mr squared. Then the 1/2 is different for each shape, but in this case it's 1/2. So the torque is going to push the ball to the ramp, and so going in a circular path. And this thing right here is the board that's underneath the disc, which is causing the ball to not fall. But once it gets over here, there's not going to be a board in that spot, so it's going to fall down to the ramp. The kinetic energy of the disc is going to, which is actually 1/2 I the omega squared, and that is the rotational kinetic energy, and that's going to turn into well, we have to transfer it to linear kinetic energy, which is 1/2 mv squared. And that the reason is because once it drops off over here, it still has that horizontal kinetic energy. So you still have to count that. So it turns to kinetic energy linear. And then once it goes here, the force that is moving the ball in this direction is the gravity. And how we calculate the force, which is moving the ball downwards, we use the gravity, which is mg, and the normal force. So we use some triangle math, and we get mg equal mg times sine theta, and that's the force that brings the ball downwards. And since it's a force, it has acceleration because of this equation F equals ma. So since it's at an angle, it has two forces, and it has one horizontally, one vertically, and the vertically one is no more because of the straight surface that is on. So then we just have a horizontal acceleration, and it's going to launch off the system.